Okay, we are looking at the first lesson in our Unit 5, Relationships and Triangles unit. This first lesson, we're talking about the angles of a triangle, and we did this in class, but if we were to take a triangle, cut it out of a piece of paper, cut off the three angles, tear off, however we wanted to do that, and then put those angles back together with the vertexes all touching and making the sides adjacent, we would end up with a straight line. These angles would have a sum of 180 degrees, which is the case no matter what type of triangle we have. So what can you conclude? They add up to 180 degrees. Now, if we were to take these two angles, 1 and 2, and do the same thing, they would be equal to what we get in angle 4, which is what we did in class, which means that when we take angle 1 and we add it to angle 2, it's equal to angle 4. And we'll see, this will make a little bit more sense coming up in our notes. But when we add up the angles of a triangle and they add up to 180 degrees, this is called the triangle angle sum theorem. The angles of a triangle add to 180 degrees. An equiangular triangle has three congruent angles. All the angles are equal, and again, they still must add up to 180. So in order to figure out what they are, we take 180 degrees, divide it by 3, which will give us our angle measure for each angle, which is 60. And that is the reason why. 180 divided by 3 equals 60. In a right triangle, the relationship of the two measures what is the relationship of the measures of the two acute angles? So we've got a right triangle. Well, it's 90. What's the relationship of these two angles? Well, if a triangle is 180 degrees and we take away the right angle, which is 90, we're left with 90 degrees. That means those two angles should add up to 90, which means they are complementary. And the last part of this section, there can be at most how many right or obtuse angles in a triangle? Well, the answer is 1, because if we have two right angles, that's 90 degrees plus 90 degrees, which is 180. Well, that's only two angles equaling 180, so we cannot have three angles measuring 90. We cannot have two angles measuring 90 or greater. All right, now here's a proof we're going to look at to kind of prove this triangle angle sum theorem. So we have triangle ABC. If I was to draw a parallel line to AC so that these two lines were parallel, and we labeled this angle 4 and this angle 5, you would all agree that angle 4 plus angle 2 plus angle 5, they form a straight line, straight angle, which is 180 degrees. Well, because parallel lines are parallel here, angle 4 and angle 1 are alternate interior angles, so angle 4 is congruent to angle 1. Likewise, angle 5 is congruent to angle 3. And through substitution, we can replace angle 4 with angle 1 plus angle 2 plus angle 5, which we can substitute with angle 3, equals 180 degrees. Which now that goes to show you that the sum of our angles in our triangles, 1, 2, and 3, equals 180. Okay, the important part, what I want you to get from this section right here, is that a couple of definitions and terms. Here we have our triangle. The angles inside are called interior angles, and we can make an exterior angle by extending one of the sides of our triangle. This is our exterior angle, just like the example we did in class with the paper where we cut it. The exterior angle theorem says that the exterior angle of a triangle, right here, is equal to the sum of the two remote interior angles. And what they mean by remote is the two angles not connected or adjacent to the exterior angle. So this angle is equal to the sum of the two remote exterior angles. Very similar to that where we cut the triangle and we put angles 1 and 2 on angle 4. The theorem proving this, well, we're given that ABC is a triangle. 3 and 4 are a linear pair. We see that in the drawing. That's definition of a linear pair. 3 and 4 are supplementary. Well, the linear pair theorem says that if it's a linear pair, then they're supplementary. And if they're supplementary, then the measure of angle 3 plus the measure of angle 4 is equal to 180 degrees, which is the definition of supplementary angles. Well, the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 because of the theorem we just learned, the triangle sum theorem. Where the measures of the angles of a triangle add up to 180. And now we can substitute that, set them equal to each other because the measure of angle 3 plus the measure of angle 4 is equal to 180, which is also equal to the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3. Substitution. Now if we subtract the measure of angle 3 from both sides, we end up with the measure of angle 4 equaling the measure of angle 1 plus the measure of angle 2. Again, that is subtraction. Okay, let's look at a few examples using these two theorems we've learned. All right, this first example. The diagram shows the paths of a softball in a drill developed by 4 players. Find the measure of each numbered angle. Well, if we're looking at this triangle, I have 2 angle measures, so I can say 43 plus 74 plus the measure of angle 1 is going to be equal to 180 degrees. Add those two up and we get 117 plus angle 1 equals 180. Subtract 117 from both sides and angle 1 equals 63 degrees. Well, if angle 1 is 63 degrees, what's the measure of angle 2? It's also 63 degrees because they are vertical angles and vertical angles are congruent. Which now says that if angle 2 is 63, then 63 plus 79 plus the measure of angle 3 is going to be equal to 180. Because again, the sum of the angles of a triangle equals 180. Combine like terms and we end up with 142 plus measure of angle 3 equals 180. Subtract 142 and the measure of angle 3 is equal to 38. And there we have all our angles, 1, 2, and 3. Alright, now below this example, and actually the next 2 examples, uses the exterior angle of the triangle because we are going to use the exterior angle theorem that says the exterior angle is equal to the sum of the 2 remote interior angles. So 2x minus 48 is equal to x plus 32. Subtract x from both sides, add 48 to both sides, and we get x equals 80. Now remember, that's not my answer. They want the measure of FLW, which is that right there. So we're going to substitute that. 2 times x, which we found to be 80, minus 48. 160 minus 48, and the measure of angle FLW equals 112. On the next example, same situation. We've got an exterior angle equaling the sum of the two remote interior angles. So 3x plus 10 is equal to x plus, we don't have an angle measure, but it's a right angle, which means it's 90 degrees. Subtract x from both sides, subtract 10 from both sides, and we get 2x equals 80. So x equals 40. Now remember, they're looking for ACD, so let's try that. We've got to plug that into 3 times x, which was 40, plus 10, which means that the measure of angle ACD equals 130 degrees. And the last example in our notes, this one's going to get kind of tricky because I'm just going to make this big right here. We're going to need to find the measure of each of the missing angles. Let's look. The one I think is the easiest right off the bat is angle 5, because we have 41 and a right angle, which is 90, which means angle 5 plus 90 plus 41 equals 180 degrees. 90 plus 41, angle 5 plus 131 equals 180. Subtract 131, and the measure of angle 5 equals 49 degrees. Okay, now the next one that I would look at angle, let's see, 3. We have a straight line here, so all these angles are going to add up to 180 degrees. That leaves us with a right angle, which is 90, angle 3, and 48 degrees. And that's going to equal 180. Combine like terms, 138 plus angle 3 equals 180. Subtract 138 from both sides, and the measure of angle 3 equals 42. Okay? So angle 3 is 42. Well, I know that angle 1 is vertical to this angle right here. So this angle, if I find it, will give me angle 1. So I have 42 and 34. So 42 plus 34 plus this missing angle, which we'll call x, equals 180. We end up with 76 plus x equals 180, and subtract 76, and x equals 104. So if this angle is 104, then angle 1 is also 104. Okay, we're getting close now. Now, angle 1 and angle 2 form a linear pair, so that's going to be 180 degrees. So if angle 1 is 104, then angle 2 plus 104 should equal 180. Subtract 104 from both sides, and the measure of angle 2 is 76 degrees. Now we need to find angle 4, our last one. The only problem is we don't know what this angle is right here. I do know that I have a 90 degree angle and I have 34, so if I take 90 and subtract 34 degrees, that gives me 56, which means this angle is 56. So 56 plus 76 plus angle 4 equals 180. And then we just do the math. 132 plus angle 4 equals 180. And the measure of angle 4 equals 48 degrees. If you had done that different ways, there's so many different ways you could have done that. You actually could have used parallel lines. Since we had two right angles, those lines are parallel, and we would have had alternate interior angles to prove that those were 56. So many different ways to do this. Looking at the homework, let's look at the problems that will give you the most trouble. Okay, number one, very similar to the one we just did. You're going to use the rules of triangles, also parallel lines. You'll be using some of those linear pairs. 3, 4, and 5, what the question is asking is you have a right angle. One of these angles, for instance 44.9, is there. What is this angle? What is the missing angle? So you'll just have to add 90 plus this angle plus your missing angle. Number 6, we haven't talked about this, but if we have two lines here saying these two lines are congruent, it means that these two angles are going to be congruent. That's an isosceles triangle. Number 7, you should be fine. Number 8. Number 8 was the one that we went ahead and we skipped that one, so we're not going to look at that one. Number 9, those two angles are congruent. We haven't really talked about why, but they are. These two angles are congruent. These problems are some tricky ones, but there's nothing there that we haven't talked about or gone over or you should have trouble with. And this last one, we have 4 different problems. We have this problem, which you're just solving for x. Remember, isosceles means that these two angles are congruent, these two angles are congruent, and these two angles are congruent. That should help you solve that. Solving the system, if y equals that, well, through substitution, we get to the conclusion that x plus 2 equals 2x plus 1. That allows us to solve for x. We then plug it back in to solve for y. Okay, hopefully this helps you with the homework assignment. Good luck.